It's a sign day. Oh, yay. Howdy. Welcome to M2 Antenna Systems. Right now, we're going to be looking at an eggbeater-style antenna and being able to apply signals to both of the two active transmit and receive elements. So, what we've got is a sine wave generator, which we have currently conveniently tuned to 145 megahertz. We're going to use an oscope, and we're going to trigger on that, which is coming from the sine wave generator and going in channel 1. Channel 1 in this case is yellow. Now what we want to look at is we want to look at the outputs from some of the different ports on our little test board, just to see what they look like. And so we're going to grab channel 3 for now, and we're going to have a quick look and just see what we look like. Now, the grounds on this functionally are virtual grounds, so I'm going to cheat for the sake of this video and just look at that sine wave. And I want to see how much time delay I have relative to the main sine wave, because this pink sine wave is going to be my reference for the other 3 ports. So the first thing I'm going to do is I'm going to move this marker right to the 0 crossing, where this sine wave goes from most negative through 0 towards most positive. And initially, I'm just going to compare that to our trigger sine wave, but eventually I am going to be comparing that to the green trace once I make it active. And right now our delta time between these two sine waves is 1.2 nanoseconds, as measured there. Now, the idea here is to apply 4 different quadrature signals. And quadrature just means in phase, 90 degrees out of phase, 180 degrees out of phase, 270 degrees out of phase, to the 4 sides of the active element. And we'll throw that inside here, and we will be applying 0 and 180 on one side and 90 and 270 on the other side, giving us a transmitted circular polarization depending on how you phase shift this relative to this. Leave this one at 0 and 180, and if you make this one 90, 270, you get a right-hand circle pole. If you make this 270 and 90, you get a left-hand circularly polarized signal. And we run that into an egg beater of various frequencies. In this case, this one's a 436 megahertz M2 Antenna Systems egg beater. And we also have another version over there, which we've also developed against, which is the 144 megahertz egg beater. Now in this case, this one is fully built, complete with the reflecting ground plane. And conveniently, there's no high power going into it, so I don't have to worry about baking my little noodle. So, that's what we're doing at the moment, and we're looking at this in time domain rather than frequency domain, so that I can sanity check and verify my phase shifts are correct. Hey, once again, thank you for visiting M2 Antenna Systems, and keep transmitting.